This video is made possible by PCBWay, who kindly sent me some boards at no cost. New members get $5 off their first order, links in description. See, my boards came in. I got a little sack of these little guys too, the true bypass breakouts. See the main boards in here. I'll grab a fresh one out of here. Now, I actually had a little bit of trouble getting them working. It's not PCBWay's fault, who, by the way, made this project possible. See, I called it the Op-Awesome Op-Amp Octave Switching Modulator. It says in little text right there. Maybe I should zoom into this. That would work. Pretty standard gloss black. Oh, I actually had another one of these that I soldered up. I had so much trouble getting it working, and I think it was due to a problem with the bypass board, although looking at the way it's wired, I can't really see anything. And I even tried turning the bypass switch 90 degrees and whacking it in there, because I noticed something interesting is that the switching pattern does not follow the ribs on the bottom of the switch. But that just made the problem different. So what I did instead is I just jumpered all the connections, 1 and 2, 1 and 2, 3 and 4, 5 and 6, and 7 is just ground for that 10 meg ohm resistor, which would be right here at R11. So they also sent me this little snowman kit. I'll zoom out on that. Came with a little battery holder. I'm not going to open it right this moment, but I will assemble it in just a minute. It's got all these weird little controller chips, so it should do something pretty interesting. Let's start with the snowman kit. Real interesting. I don't think I've ever been sent something like this before. I've seen them around though. Okay, the only loose component they gave was, of course, the battery holder. What are these chips? This chip is it appears to be some kind of obscure microcontroller. I'm just guessing because of this programming footprint here, but yeah, it says T10H8 36080. So I looked it up and no results. I tried T10H8. I tried 36. I tried both numbers, both lines one at a time, all at once. It's a mystery chip. Must be one of those new microcontrollers. Either that, or it's one of those weird non-unique markings. And this one, I can't even understand what's on here. It just looks like a garbled jumble of symbols. But, whatever. Let's heat up our soldering iron and okay, load this one in here. Okay, let's try this again. Got some fresh batteries. It's real delicate. So according to the website for this being the 2018 Christmas card, the PCBWay variant was produced without our logo and have been delivered to customers of PCBWay. As far as we know, this card is partially assembled and the MCU is not programmed. This post will serve as an as-is instruction for those who want to make their PCBWay variant operational. Yeah, I'll have to touch that later. The crustiness you see on the board is not the board itself, it's some flux that hasn't been cleaned up. You can see the finish of the boards I received was actually quite clean. Actually a pretty good quality board so far. I haven't had any problems with lifting, so that's good. Of course, little bag of boards that I got, I think I had problems with, but it was my fault and not PCB ways. So, also, if you notice why I have this weird little coupler back here instead of the DCO22B, it's because the DCO22B has to be inserted into the panel before it is soldered, because the way it's threaded on the back, whereas these jacks are threaded on the front. So anyway, I've got this 15 watt practice amp that I keep out here in the shop for testing. So in the one I usually use is a bass amp that I have in the house. Okay, it's a little noisy. That's what I'm having problems with. And so that's what I have here. Of course, I still have a half-assed octave. It's because it's loaded too much. The buffer doesn't directly connect. It was kind of routed around the buffer, and in hindsight I shouldn't have done that. It's not as good as the one I have on the breadboard, which is I'm currently designing an improvement to this. However, you know, it doesn't have the modulation feature, which by the way on this one is kind of noisy. You can see it bleeds too much into the mix, which it seemingly didn't, but I think it's because the connections are so good. But yeah, I tried messing around with the R5, which is the series resistor, and with varying degrees of success, but none of them satisfactory. So I figured, you know, the modulation effect is pretty much, it's just a tremolo slash, you know, ring mod. also get cool ring modulation tones if you play multiple notes while on full octave. Now the octave effect is quite strong, so that's why this is... Oh, here's someone's motorcycle outside, by the way. The octave effect is quite strong, so it even kind of gets into... I might have to get a wider range pot than this. This is a 200K. I might want to go with a, maybe a 500K, because there you can still hear the ring modulation effect of the octaver. Oh, what did I touch? Workshop is kind of a mess at the moment. As you can see, I did do a little experimental housing for my board, and I bent it on this Harbor Freight sheet metal brake, which I think has kind of a dumb design here, but used a radius of, I believe, 1/8 inch. So yeah, got some sheet metal real cheap from the REMS stack at Competitive Metals, so that's neat. Anyway guys, I hope you liked this video. Don't forget to like, comment, and subscribe. And until next time, thanks for watching.